Students, welcome to the last video here on the lesson on side angle side and hypotenuse leg. And here we're being given one, two, three pieces of information along with the picture, and asked to prove that these two triangles are congruent. So the first thing that I will do is just label all the things that we know are true based on the given. So OS, or sorry, that should be QS. Okay, that should be a Q here, I don't know. QS is congruent to PR. So the entire thing here, QS is this entire length is congruent to PR. And this is, keep in mind, again, it's the entire length. It's not just a segment of it. PS is perpendicular to RS. And here is where you absolutely have to know definitions, because if you know this, then you know that PS and RS are perpendicular. That means 90 degrees. So this corner here is 90 degrees. And then finally, QR, that's this segment, and RS is also 90 degrees. So QR is this segment, RS is the segment that's going across the top here, and this is also 90 degrees. Okay? And as I did before, what I'm going to try and do is highlight the triangles here and just separate them. So PRS, so that is this triangle here, and then QSR. Okay. So QSR is this red triangle here. QSR. Okay. So, and then what I'm going to do next is just redraw these two pictures and just separate them. Okay. So I've just really taken this picture and separated them into these two pictures here. Okay. So the yellow triangle is PRS, and the red triangle is QSR. All right. And then I've redrawn all of the congruent and the 90-degree angles. So this part here, PS and RS, that's 90 is perpendicular, so that's 90 degrees. QR and RS, that's also perpendicular, so that's 90 degrees up here. And then we know that it's given that QS is this line here. That's congruent to PR. That's this line here. Right, so I've separated those two parts. Okay. So part of my proof, I'm going to use the hypotenuse leg theorem here to make this proof work. Part of my proof, though, is going to rely on the fact that they're both 90 degrees. So I'm going to say both triangles, okay, are right triangles. Okay, so that's important, and that comes from the definition of perpendicular. Okay, it comes from the definition of perpendicular. Okay. So that's a really good start here. And then I'm going to say that PR is congruent to QS, and this is just given. That's very helpful. Right. So now I have hypotenuse. So I have a hypotenuse here and another hypotenuse here that's congruent, and all I need is a leg. Okay, one of these legs are either SR or SP and RQ. But if you look at this picture, before I separated them, SR, this line here, the horizontal segment across the top here, it's shared by both the yellow triangle and the red triangle. So I've separated the picture so that you can see it easier, but it doesn't change the fact that they are in fact the same segment. So I can say that SR is congruent to RS, and this is the reflexive property. And we use the reflexive property whenever you have two triangles or two figures that share the same segment, then we can say that they're reflexive, okay? And reflexive basically means it's equal to itself, like looking at a reflection. So, and this is the leg. So you have a leg up here and a leg here. So you have two hypotenuses, or hypotenuse, that are congruent, and then two legs that are congruent. So that means, and they're both right triangles, so that means we can use the hypotenuse leg. So we use PRS is then congruent to triangle QSR, okay, and this is by the hypotenuse leg there. And there you have it. That's the end of the proof. We're essentially demonstrating that you have two right triangles, and they are in fact congruent to each other. And as always with proofs, it's not easy because there's not a simple step-by-step process that you can follow. All there really is a bunch of strategies that you can practice and get better at a little bit at a time. Keep working on this. If you keep working on it, I'm sure you'll get it. As always, ask for help if you need it. Thank you for watching, and have a wonderful day.